number of permutations without repetition is nothing but NPR. It is also denoted as P of n comma r, and the formula we have just now derived is n factorial upon n minus r factorial. Number of permutations now with repetition is equal to n power r. So understand the difference here with repetition and without repetition. So that's what you can see in the first slide, that is derivation of P of n comma r n factorial upon n minus r factorial. That's what just now I derived it. Arrangements with repetition also, it is n power r. Okay, so next is the number of permutations of n dissimilar things taken not more than r at a time, when each thing may occur any number of times, is n into n power r minus 1 upon n minus 1. What does it mean? Just go through the definition once, just to go through the statement once, rather I can say. The statement here is the number of permutations of n dissimilar things. All the things should be dissimilar. Then you may think, if the things are not dissimilar, what should it be? We'll come to that next. So if n things are dissimilar things taken not more than r at a time, not more than r at a time means you can take one thing, or you can take two things, or you can take three things, or you can take four things, and so on. You have to take maximum of r things, and always remember n is greater than r, of course. Okay, now if one thing is taken, it is n power 1. If two things are taken with repetition, n square. Just now we have seen the formula, it is n power r. With repetition, n square, plus three things are taken, it is n cube, and so on. R things are taken, it is n power r. Now if you take n common, it is 1 plus n square plus so on plus n power r minus 1. You can clearly see that it is a geometric progression. Sum of n terms of GP is nothing but n power r minus 1 upon n minus 1. So the number of permutations of n dissimilar things taken not more than r at a time. What does it mean? Not more than r at a time means in this case we have taken only one. In this case we have taken two. In this case we have taken three. In this case we have taken r, maximum of r. So the sum of all these will give you n into n power r minus 1 upon n minus 1. This is sum to n terms of GP. So you understand that. So now how many number of functions and others can be defined using this? This is an important thing to be understood. But before that, you must know the definition of a function. Simply, I'll tell you like this. F maps A to B. What is A? You know, A is the domain. What is B? B is the codomain. Okay. Now, the domain is consisting of, let me say, 3 elements, and the codomain is consisting of, let me say, some 5 elements. This is A, this is B, and the mapping F. Let me say, if F is to be a function, then what is the rule to be followed? Then you will better understand a function if you understand what is not a function. What is not a function? If any element of domain, is without association to the set B, then it is not a function. It is not a function. So understand, every element of domain must have exactly one and only one association with the set B, and this is not a function. That's what I'm explaining. It is not a function. If any element is left without association, then it is not a function. Then it is like this, and it is like this. If any element of domain has more than one association, then also it is not a function. These are the two things you have to remember. You have to remember what is not a function. If any element of domain has more than one association, then it is not a function. If any element is left without association, then also it is not a function. Now, our interest in permutation, using permutation, can we write the number of functions? If f is defined to be a function, can we write the number of functions? Okay. Now, according to the definition of the function, let A and B be two non-empty sets. Let A and B be two non-empty sets. And to every element of set A, exactly one and only one element of set B is associated, then f is said to be a function. This is a better example is if you take your classroom and let us suppose there are totally 30 students in your classroom, and on that day only 25 students are present and 5 students are absent. Then if your teacher comes and calls everybody's name from the attendance register, let us suppose that it as a set A, and if your teacher is calling the attendance, then 5 students will not have any association because they are absent to the class. Then it is not a function. It's not a function. Unlike that, if the teacher comes and he or she is asking your name and she is marking here, that means the number of students present in the class is taken to be set A, and set B is the attendance register in her hand or in his hand. Then set A to set B will be definitely a function, because everybody in the class will have a unique roll number, and everybody will be associated with the attendance register. So that is a simple example for a function. So now here we are interested to know how many functions that can be formed in this case. Now, x1 can be associated to any one of these 5. That means x1 has how many chances here? 1, 2, 3, 4, 5. So x1 can be associated to any one of 5. So x1 has 5 chances. And similarly, x2 has also 5 chances, and x3 also has 5 chances to be associated. So first operation 5, second operation 5, third operation 5. So it is nothing but 5 into 5 into 5. It is 5 cubed. In what way this can be related to this? This is 5 is nothing but n of b. It is number of elements in set B. And 3 can be said as n of A. So n of B whole power n of A. N of B whole power n of A is nothing but the number of functions. You might have understood this now, how we derived this using simply the principle of counting. So the number of functions to be concluded here, the number of functions, what are the number of functions here? Number of functions, total number of functions, I can say, total number of functions for f maps A to B is n of B whole power n of A. Understand it, please. N of B whole power n of A. That's good. Now, this is total number of functions, and you know the 1-1 function. What is a 1-1 function? 1-1 function, f maps A to B is said to be 1-1 function if to every element of set A, exactly one and only one element of set B is associated. Just now we have taken the example. That is a 1-1 function. What is it? The number of students present in the class is set A and the attendance register is set B. Then if you map the number of students present in the class to the attendance register, then it is nothing but a 1-1 function, because no student in the class will have 2 roll numbers. No student in the class will have 2 roll numbers. That is, everybody will have unique roll number. That is why that is nothing but a 1-1 function. So number of 1-1 functions means if you take this one, the same example, x1, x2, x3, and y1, y2, y3, y4, y5, x1 map it to x3, x2 map it to y1, and x3 map to y5. Is it a 1-1 function or not? Definitely it is a 1-1 function, because every element is associated with different elements or distinct elements of set B. So that is why it is said to be a 1-1 function, or rather you can say it's an injection. So now our interest is how many injections that can be formed. How many injections that can be formed? Very simple, very simple. I'll take like this. For x1, how many elements can be mapped? 5 elements can be mapped. For x2, because x1 is already mapping with one of these elements, x2 will not have 5 elements, but that will have only 4. So second operation can be performed in only 4 different ways. And if you come to x3, because x1, x2 are already mapping to any 2 elements of these 5, only 3 are remaining. So that is nothing but 3. So first operation 5, second operation 4, third operation 3. So it is nothing but 5 into 4 into 3, which is nothing but 5p3. So, what we have derived, it will be clear now for you. It is what is the difference between n power r and what is the difference between n power r and npr is clear now. Previously, we have derived it to be 5 cube, the number of functions. But 1 functions is 5p3. Understand? That means without repetition, it's nothing but number of 1 functions. So I can say this 5 is nothing but n of b and 3 is nothing but n of a. So number of 1 functions or injections is equal to n of b p n of a. N of b p n of a. So understand it, how the permutation is applied. Permutations is applied to find out the number of functions is this one. That is there the total number of arrangements. It is nothing but total number of functions. There n power r, it is n of b whole power n of a. And the total number of arrangements of dissimilar things without repetition is npr we have derived, and it is n of bp n of a. It is nothing but 1 function. So now total number of many 1 functions. How do you understand this? Many 1 function is nothing but if at least 2 elements of set A, at least 2 elements of set A is mapping to the same element, then it is said to be many to 1 function. Many to 1 function, understand that all non-1 functions are many to 1 functions. What did I say? All non-1 functions are many to 1 functions. The total number of functions are these many. Total number of functions means what? Every function will be present in that one. Every function means 1 function is present, on2 function is present, constant function is present. Every function, many to 1 function is present. Every function is present in n of b whole power n of a. Then what do we need? We need many 1 functions. Many 1 functions are nothing but non-1 functions. Non-1 functions means you subtract that n of b whole power n of a minus n of b p n of a. So understand how this can be applied to the concept of functions. You might have understood this, the application of the same permutation and in the functions. So not only this, you can derive the constant functions also. How many number of constant functions will be there? What is a constant function? Like constant function is in the form of fx equal to k. So if you have same example x1, x2, x3, y1, y2, y3, y4, y5, let me say, then what is a constant function? x1, x2, x3. All the 3 elements should be mapping to only y1. And similarly, all the 3 elements can be mapped to only y2. All the 3 elements can be mapped to only y3. So how many different types of constant functions you'll get? The number of elements in B. Number of elements in B is nothing but the number of constant functions. So you can have the number of constant functions also from this one, that is number of constant functions is equal to n of b, understand, that is the number of elements in the codomain is nothing but a number of constant functions. Okay, so this is how we can relate this to find out the number of functions and number of one functions, number of many one functions, number of constant functions. Okay. Now, let us see the next one. Like and dislike things. What does it mean? There are n things and r things are like things. N minus r things are distinct things. Distinct means what? Different. Distinct or different or same. Distinct things are there. So totally how many things are there? N things are there. And what is the data here? Among n things, r things are like things and n minus r things are distinct things. Then in such a case, what should be the number of arrangements? Number of arrangements, always remember, like I'll explain you briefly the meaning of it. Mathematics is there. If you have mathematics, how many alphabets are here? 4 plus 4, 8 plus 3, 11 are there. And in fact, without any repetition or without any like things, they can be arranged in how many different ways? 11 factorial ways, or rather you can say it as 11p11 ways. 11p11 is nothing but 11 factorial ways. But what happens? You have 2 m's present here. You have 2 a's present here. You have 2 t's present here. Then when you rearrange them, what happens? If you write this m here and replace this m with this one, these m's are replaced. These m's are replaced or interchanged, I can say. Interchange. Is there any difference there? No. That means this 11 factorial will be more if you have this type of like things. This type of like things. Like things means if you take all the bananas are like things. Generally, in the nature, whatever is created by the God are all, you can take them as different things. Whatever are created by the human, some are like and some are dislike. That means the things that are created by God are all to be treated as different things, and the things that are created by human are to be, some are like things and some are distinct things. So here in this case, whenever the repeated things or like things are there, then you have to count their number and you have to divide with their factorial, and simply I'll explain you like this.